Find the volume of the solid of revolution formed by rotating the region bounded by y equal 1/2 x plus 1, x equal 2, and y equal 1 about the x-axis. This is the exact region that we did with examples when we were finding volumes by washer, but now we're going to use the same region rotating around the same axes and find it by the shell method. So first we need to sketch our region again. So we'll go ahead and put that region here, and we'll make this kind of spread out a little so we can see what we're doing. So we need to plot the line y equal 1/2 x plus 1, so it has a y-intercept of 1, and we'll go up 1 over 2. So there's our line, and then we are going to plot the line x equal 2 and y equal 1. So this forms a triangular region, and we could figure out the corners. This is the point 2, 1. This is the point 2, 2. And this is the point 0, 1. Now in this problem we want to rotate this about the x-axis. So we're looking here rotating around the x-axis. Now we need to look at a representative slice to figure out what our shells would look like, and when you're doing the shell method, that representative slice will go parallel to the axis of revolution. So my slices are going to go horizontally here, so I can see that the little thickness would be a dy, because we have our horizontal shell, so it's little thickness dy. So that means when we integrate, everything's going to be in terms of y. So our limits of integration are going to be in terms of y, so we're going to go from 1 to 2. And we need to express this in terms of y. Now remember, when we're doing shell, it's like we have this shell, and this is the outer edge of the shell, and it's wrapped around here. So we have this shell like this. And so when we open out that shell, we see that the length of the shell, which went right around here, if we straighten that out, it looks like this. And this length is 2 pi r, because it was wrapped around here. It was the circumference of that circle. And then we need to know this height right here, and that's simply going to be the length of our little slice here, and that's going to vary depending on where we are here, so we're going to have to figure out what that is. But basically we're going to sum all of these shells up then that measure 2 pi r by h. So we're going to have 2 pi, and we see that our radius, our r, is going to be measuring from our axis of revolution up to whatever y value wherever we're integrating. So that's just going to be y. But then our height is going to be, we just need to look at our picture, and we see that the height of these various shells is going to be this line here, which was x equal 2 minus the x value of this line right here. So as we look at that, if I want to know this height, I need to subtract off this little piece right here, which would be the x value of this linear function. So we looked at that and saw that it was going to be 2 minus x, but we want x in terms of y, so we solve this for x, and we have x equal 2y minus 2. So we're going to put that right here, 2y minus 2. And then we've got our little thickness dy. So there is our 2 pi r, which would be like this wrapped around length, and then our height, which was 2 minus this x value, this little red piece here for each shell. Okay, we've got our integral set up, so now we're ready to go ahead and simplify and see if we can work the integral. So let's see what we can do. We can take the 2 pi out in front of the integral, so we have 2 pi integral from 1 to 2. If we distribute this through, it looks like we'll have 4 minus 2y, but then we have this y out in front, so that's going to be 4y minus 2y squared dy. Alright, so we've got 2 pi. Now we'll go ahead and integrate here. That looks like that's going to be 2y squared minus 2/3 y to the third evaluated from 1 to 2. So we have 2 pi multiplied by putting a 2 in here, that's going to be 8, minus putting a 2 in here, 8 times 2, that's going to be 16 thirds. And then our lower limit, minus 2, putting the 1 in here, we're going to have 2 thirds, and that will be a plus. So let's go ahead and simplify that. And it looks like we have negative 14 thirds and then plus 6, which would be 18 thirds. So we're going to get 4 thirds, and then we multiply that by the 2 pi. So it looks like we got 8 thirds pi. And that's a good thing because that's exactly what we got when we did the washer method.